So we're going to talk about aniseikonia. And isoconia means not the same size. Sometimes this is isoconia like this. And aniseikonia means you have one side, the thing is bigger than the other side. So if one side is smaller, it's a micropsia. If it's bigger, it's a macropsia. And optically, the things that cause micropsia and macropsia are as if you have magnification or minification effects from the lens or your refractive error or your glasses or whatever it happens to be. So plus lenses make things bigger, and that's why handheld magnifiers are often very large plus. And myopic lenses, nearsighted glasses, negative lenses make things smaller. In most people, they don't notice this. So I am a -7 myope, but I don't notice the micropsia. The minification effect on my spectacles is not noticed by me because the two eyes are both equally minified. However, if you were aphakic or you had only one eye that had trauma and they took your lens out and you needed a big plus lens in front of that eye, if you didn't do something in the other eye, you would be bothered by symptomatic aniseikonia because the one eye would have the big plus lens magnifying the image. And so that's why we usually have to either do both eyes or we have to use a contact lens. The contact lens can reduce the amount of aniseikonia because the lens is right on your eye. And so it's closer to the focal point of the eye. However, some patients, they still cannot be fixed in terms of the amount of aniseikonia. And so they have to have a secondary intraocular lens placed in there to replace the lens that was taken out. And so normally aniseikonia is a problem with refraction, optics, something in the front of the eye that is causing the problem. But sometimes the aniseikonia is from something in the back of the eye. And in the back of the eye, we have the photoreceptor elements. And those photoreceptors each are in charge of a designated distance in your visual field. And so your brain has been hardwired to recognize how far apart things are based on how much receptive field is being stimulated by the photoreceptors in your retina. But if you push them all together, like you have a epiretinal membrane or you have some sort of structural scarring that pushes the photoreceptors closer, then you have more photoreceptors in the same area. And so your brain will think that that's bigger. So your brain will interpret the size of an object depending on how many photoreceptors are being stimulated. And if you push them closer together, it'll be illusory enlargement, macropsia, because more photoreceptors per unit area are actually being stimulated than the size of the real object. And conversely, if you push the photoreceptors apart, the same area is only stimulating 2 photoreceptors here versus 4, things will look smaller to you. So if you can imagine on a football field, we have the chains. So the guys carrying the chains mark the 10 yards that are necessary to make the first down. So 2 guys holding the sticks have a chain between them, a literal chain, and that chain measures 10 yards. And the reason they need that chain is because sometimes it's 9 yards and almost to the next yard, but it's like inches, and they miss the first down by this much. And then they raise their hands like this to show the distance. The chain physically shows that, so it makes for great television. However, if you think 2 guys equals 10 yards, if you put 4 guys in the same space, you'll think that's 20 yards, when it really only is 10. Because you're only using the guys to determine the length and not the actual chain. You're just using the guys. 4 guys equals 20 yards. This is macropsia. Too many guys in the same amount of space. And so correcting that kind of macropsia and micropsia normally requires either an optical solution, because we can take advantage of the minifying effect of the minus lens, so you can use a contact lens and a spectacle correction to minimize the size again by putting a minus lens. or a plus lens. But you have to cancel out the refractive change, so it has to balance out. Or you can fix whatever the problem is. Usually it's like epiretinal membrane or chorioretinal scar, so that might require a vitrectomy and membrane peel. And the reason it's important to know from the retinal standpoint is the difference in the size, the aniseikonia, can be a barrier to fusing the image and could cause diplopia. So if you have an 8% increase in size on one side versus the other, you're going to have a hard time fusing those two images, even though they're the exact same image, they're different sizes. And so you need to know a little bit about aniseikonia, the retinal causes, as well as the optical causes, and that we can correct it with optical means. But if it's a structural problem, you need a structural solution, that's surgery. And counterintuitively, if you push the photoreceptors together, it makes the image look bigger. And if you stretch the photoreceptors apart, it makes the image look smaller.